So welcome to the next lecture. In this lecture, we will start from the last. Okay. So in the last lecture, I have talked about equation of straight line and ended with what is the equation of pair of straight lines. Okay? So let's just start it from there. Let me give one more example of pair of a straight line. Okay. Let's see y is equals mod x. This is mod x. Okay. What does it mean? It means y is equals x whenever x is greater than 0. Okay. And x is equals minus x. Right? So that means in all the cases, y will end up generating a positive value. Right? So if we try to draw this function, how it will look like? So whenever that means at first case in positive value of x, y will end up like y is equals x, and we already have seen how y is equals x will look like. It will be a straight line from 0 0 with no intercept. So it will be like this. Now let's say if the x is negative, that time it will be minus x. That means minus x minus of minus x. That means it will be positive. So that time also it will look like this, like from this point actually. This, right? This will look like this. So there will be like there this thing, and in this region there will be no such case. The function will look like this. Okay. Like this is not pair of, you can say this is whole function like y is equal mod x. So you look like if someone asks you to draw y is equals mod x, it will be like this. So now in this case, as I told you earlier, what I will do, I will take several examples of like several equations from chemistry. I have noted it down on my copy. I will take one by one and explain how the plot will look like. So in the last lecture as well, I have talked about Boyle's law. So that you know, but I'll again tell you that one. Now for the time being, now just start with Charles law, right? Charles law. Okay. This is also one of the gaseous state law, right? What does it tell? It does tell V proportional to T. I'm just not explaining all these things because this is only for like the mathematics part I am talking about. Whenever I teach gaseous law, that time I obviously explain everything. So V is proportional to T. So if you simplify it, it will become V is equals KT where K is equals constant, right? Now just let's say if you have need to plot V versus T, right? That means that time Y is equals Fx, right? In case. So in this case, your Y is equivalent to V and your X is equivalent to T, right? Now you can simply see this as a straight line equation, okay? Equation of straight line. And how you can draw it? Just compare it with y is equals mx plus c. So whatever I told you in the previous class, you just need to do that, and you can end up with having the plot. So if you compare, so comparing with, let's say this is one, and this is your equation one. Sorry, this is your equation one. This is your equation two, right? So comparing it with 1, comparing 2 with 1, what do you get? A is equals K and C is equals 0. That means it will be a straight line, but intercept will be 0. That means it will start from color. So it will start from 0.00 and it will be a straight line. You don't know the value of K. If the K is like depending on the K, the angle will change, but it will always be a positive slope. Sure. And then like it will be a constant. That means it will be that slope, but it will start from obviously from the 0, 0, right? So if this is your V, this is the coordinate I'm talking about. This is T. So V is T. It will be a straight line with the slope is equals, right? And the tan theta, whatever I discussed in the first class. So Charles law. So see, this is very simple. If someone asks you that how V will vary with temperature, then you can simply draw a straight line and it will explain the queries. Okay. So let me take one more like equation that I already talked about. That is Boyle's law is V versus 1 by V. There is one confusion here. Like sometimes right it's like P versus 1 by V, but what Boyle said is this. This is the Boyle's law. Okay. Like you will end up this to this, but this is not a Boyle. This is a corollary of this, but Boyle told this one V versus 1 by V. So if you draw V versus 1 by V, right? V versus 1 by V, then also you will obviously get one straight line. V versus 1 by V. Right? With the slope is equals to 5. Your V versus 1 by V, you can write it like K1. This is K is nothing, okay? K is just a constant. You can write it K1 doesn't matter. So this will be a straight line. This is nothing but the famous Boyle's law. Right? Now let me take one more example. You heard about ideal gas and non-ideal gas? That like Boyle's law and Charles' law combinedly give us that ideal gas law. And there is non-ideal gas as well. The famous non-ideal gas equation is that is called what it is Van der Waals equation. If you think about the imaginary gas which is having only intermolecular repulsion, that thing it will look like P minus P into V minus NV is equals inactive, right? Right? Because B is the interatomic repulsion parameter. So this is a imaginary gas I'm talking about. But just to it will fulfill our purpose of plotting it, right? So this is one of the equation. Let's say, and you want to plot. We want to plot PV versus P. Let's say, right? Before going to that, we just all know that PV is equals inactive, right? PV is equals inactive. So this PV is anything that means this is a constant. Okay. What does constant mean? That means PV, the whole value of PV will not change with P और V. मतलब तुम P को जो भी लो, V will compensate like that. Okay, as PV remain constant. तो अगर तुम्हारा P बढ़ गया तो V will decrease such that PV will be constant, right? If let's say P को decrease किया तो V will increase because that is the Boyle's law, right? That is the Boyle's law. Let's say again, if you increase the V, that means P will decrease. So in all cases, PV will remain always constant according to ideal gas. So if you try to draw that PV versus P, right? P or B, whatever it is you want to draw. अगर कोई चीज change ही नहीं हो रहा है, that means it will be always the same value. That means it will be a parallel parallel to x-axis straight line because x में वैल्यू p का जो भी हो ये सारे एक p का वैल्यू है ना p1 p2 p3 p4 p5 whatever the value of p is pv is always constant. Obviously the v is not v, it is v1, in this case v2, and v is changing such that the pv remains constant. So pv versus p or pv versus v, it will always be giving a straight line parallel to the x-axis, whatever it is it is p or v, it will be parallel to that. Now, in this case, if we want to draw PV versus P in case of non-ideal gas, non-ideal gas such that which is only having interatomic repulsion. So how it will look like? Just simplify this minus in T, right? Okay. If we can do like if V by N is V bar, molar volume. So if we divide this with N, P bar is equals PB 8 right? V bar is nothing but V bar, and V will be having similar. I'm just simplifying it. V bar is V by N. That is the molar volume. So PV is this. Now let's say your Y is PV. It's a PV bar because both are same, right? So that means the PV bar is RT plus PV, right? RT plus PV. Now this is your Y and this is your X, right? This is your Y, this is your X. Now at a constant temperature, if you want to draw PV versus P at a constant temperature, if you want to draw PV versus P, right? What I'm doing, PV versus P. That means at constant T, this RT as a whole is constant T. RT is actually constant. So this is your C or intercept, and this B is nothing but the M, that is slope. So you will get a straight line whose intercept is RT, right? And the slope will be equal to V, that is the repulsion parameter, right? Right? Okay. On the gas as well, you know the compressibility factor Z. What does Z mean? Z means V bar, that is real, or you may call it V bar by V ideal, right? You are right. That is called the J. So you already think like this for the last equation RT plus BP, right? You know V bar ideal is means for V bar is equal to RT means V bar ideal, this is ideal obviously. V bar ideal means RT by P, right? So if you divide this with RT. So what is this equation will become? PV by RT is equals 1 by BP by RT, right? So this RT by P is equals VID. That means P by RT means 1 by VID, right? So just replace this. Then V bar, this is the real gas because I am considering the intermediate person. So V bar by V ideal, right, is equals 1 by dP by RT. So V bar by V ideal is nothing but J. That means J is equals 1 plus dP by RT. Okay, so this is the equation. What is what? J is equals 1 plus dP by RT. Now, if you have to draw Z versus P or Z versus 1 by T. Okay, Z versus P at constant temperature, in this case at constant pressure. That's these two plotting need to draw. Okay. Right? How it will look like? This I'm talking about Z versus P, let's say. So this is your Y, and this P is your X, this is your C, and the whole part is your A, right? So this will be your intercept, and there will be a straight line. So this part is nothing but 1, right? And this slope is nothing but B by RT. Okay. So this is very easy. And the similar case, I'm just talking, you just think it like that. If this, in case P, if it is 1 by T, right? Then also it will be a straight line giving us with an intercept of 1. But in that case, what will be the slope? Slope will be BP by R, right? So this is very easy. Now let's say the case. Let's one more example. Let's take one more example. Okay? That is, if your equation is such that PV bar is equals, I'm just seeing the equation and writing it down, plus B minus A by R, right, into P. This is something about the Mandelbrot equation. It is like a real equation of Mandelbrot. Okay. Now, if you want to draw, in this case, PV bar versus P. This is the task we have given. Then how to draw it? PV bar versus P. Okay. So you know this. So this is nothing but the Y. This is nothing but the X, right? And this is your slope. Obviously, whenever I am talking about PV bar versus P or that time T is always constant, right? And this is your intercept. So now you see your slope is what? B minus A by RT. You know, B is intermolecular repulsion parameter and A is nothing but the attraction parameter, right? So whenever B is greater than A, B is greater than A, it just let's say slope is in. B is whenever B is greater than A, that means this whole term B minus A, okay, B minus A will be positive, right? If B is greater than, that means A will be positive. Whenever the other case is happening, A is greater than B, that means A will be negative. So depending upon the value of A and B, depending upon the value of A and B, the slope will change. Now the intercept is always RT. So there will be an intercept that is value of RT, right? Now, so this is the RT line. Now, whenever B is greater than A, we will get a straight line like this. Whenever it is less than A, we will get a straight line like this, right? And this is PV, this is obviously PV versus, right? And this is the ideal gas line. Whenever it is nothing, like there is only RT, that means PV will be RT. So that thing with the change of P, PV is never going to change. So this is the ideal line. But this is whenever B is greater than A, this is A is greater than, right? This time the slope is positive slope. This is negative slope. So this is very, if you have the basic knowledge of a straight line, then you can very easily draw and comment about the cases. Okay, right? And even just as a matter of fact, I'm telling, just see at very low pressure, at a constant temperature, because this whole plot is at a constant T. Whenever the pressure is less, like pressure is 0, or in the very low pressure region, you may say the PV versus P plot is actually behaving like an ideal one. That means at low pressure, at any constant temperature, obviously, constant temperature, at low pressure, real gas, rather you can say van der Rohe gas behaves like ideal, right? So this is the take home. Now this plotting is very famous whenever you are doing kinetics. Whenever you are doing chemical kinetics, that time the plotting is very, very essential. People will generally ask like how will the reactant reactant concentration changes with time, how the product concentration changes with time. So I have written some like chemical kinetics equation here, and I will try to solve it. Okay. So first, just very briefly introduce what is chemical kinetics. Chemical kinetics is nothing but A to B. From A reactant to B product is happening. So now if at 0 time, if the concentration is A, this is 0, at T is equals 0. Now at time, any time T, this will become A minus X and this will become X, right? This is the basic thing. Now if the order of the reaction, what is order of the reaction? I will not tell here. You just need to go back to your chemical kinetics. So whenever it will come, go back, or whenever it will come into your curriculum, or whenever I will be teaching the chemical kinetics, that thing I will explain. But order is nothing but you can say how in what way your reactant is contributing towards rate. You can say in a very simplified manner. Okay, so depending upon the order, the reaction rate will look like So now let's say this order, this is a zero order reaction. That means dx by dt will be like k into x. So there will be k into x to the power 3, right? That means there will be no effect of the reagent. This will be like this. So if you solve this, you will get x is equals kt. This will be the rate equation. X is equals kt. So this is the product. X means concentration of product. So product at any time, right? What is the concentration of reagent? That is A minus X. So it will be A minus KT. Sorry. So A minus X is the at any time what will be the concentration of reactant. So it will be A minus X means A minus KT, right? You know what is happening with this. Pause it here. So as we discussed, so I'm not solving this, but whatever we have got is X is equals KT for a zero order reaction, right? For a zero order reaction, this will be X is equals KT. So what is X? X is at any time. At any time, what is the concentration of the product? Okay, how concentration of product is changing with the time, and then what is the concentration of reactant at any time? That is A minus X. That means A minus KT. So if someone tells you, sorry, if someone tells you to draw this plot, right, to tell the time how the concentration of product is changed. Now you know this is KT. That means this is and the concentration, that means this is the product concentration or concentration of this third button means of this concentration. So if you want to draw P versus T, then this is nothing but your Y, and this T is nothing but your X. So this is Y is equals mx, and C is 0 obviously. So this will start from this and go like this, right? Now what will be the slope? Slope will be the rate constant. This will be your slope. Similarly, what will be the reactant? Like what will happen for reactant if this is say reactant concentration at any time is R? It is A minus KT, right? This is also one of the straight line, but here the intercept is not 0, it is A, right? That means the intercept is A, and the slope, that is also is not K, it is minus K. So that means from some point, that is A, because the initial concentration, that is also A. Fact T is equals 0 at 0 time. A amount of concentration, A amount of reactant is there, and from there it is decreasing, right? Right? So it will be like this, and the slope is obviously this is right. And also see that whenever the T is equals A by K, it will be 0. You just check it by yourself, you will find it. Okay. So let me go to some different. So okay, so this is your home, right? What is the first order reaction rate law? It is nothing but ln A by A minus X is equals KT. The convention is still same. This is A at T is equals 0. This is 0. This is A minus X at any time T. This is X. So if you just integrate the places, this is A minus X at and it's a first order reaction, that means this will be 1. So if you integrate it, you will find out this ln a by a minus x. Now the question is, if you plot ln a by a minus x with time, how it will look like? I will not tell the analogy. You know, this is very simple, but it will be like this, right? With a slope k. Okay, so let's stop here, right? And then we'll meet with some more difficult equation we'll learn at first, and then similarly we'll go by the things like we'll find out some chemical equation. These are very popular, and then try to solve. Okay, so let's stop here for today and meet you in the next class. Thank you very much.